Right, section 11-2, this is volume of prisms and cylinders. And we're going to start with example number 1. In example number 1, we are finding the volume of the prism, and I hope we see this as a rectangular prism. This is just length times width times height. So we first, again, just like the other sections, start with the formula. And then we start plugging things in, and on these types of problems it does not matter which one is the length, width, or height. You basically just plug them in any order. So we'll just do 7.5 times 2 times 4, and we can multiply those in any order. That's called the commutative property. I'm going to do 2 times 4, which is 8, and 8 times 7.5. I think that's easier to do. Looks like we get 60 with 1 decimal, so looks like we get 60 inches cubed with a little 3. So pretty simple problem on that one. That's number 1. Moving on to number 2. Alright, and on this one, this is finding the volume of the triangular prism for number 2. Much like the last one, you don't have to write this down, but the last problem we did was a rectangular prism, and we used the formula LWH. And what I want you to know is the LW is really a big B, and big B stands for, this is where you can really pay attention, big B stands for the area of the base. Well, in a rectangular prism, the base is a rectangle. So if you're finding the area of the base and the base is a rectangle, then you're finding the area of a rectangle. And the area of a rectangle is the formula length times width. So what happens is this big B is a formula. So it turns into LWH. On this problem, we're not using that. But anytime we talk about prisms, we always use big BH formula. Big B turns into an area formula. Well, in this case, we have a triangular prism, so the bases are the triangles. So in other words, since big B stands for the area of the base, you must find the area of the triangle. The base does not mean the bottom, so you're not finding the area of the rectangle on the bottom. You're finding the area of the triangle, since that's called the base. And so when I plug this in, I'm plugging a formula in for big B, much like the LW plugged in for big B on a rectangular prism, 1/2 BH plugs in for big B on a triangular prism. And now from this point, we're just plugging things in. The 1/2 BH is all talking about the triangle. The base is 4. The height is 3 for the triangle. So this is 1/2 times 4 times 3. Now this other h, it's different than this h. This h is the height of the triangle. Since we're only talking about the triangle, this h is the height of the prism. Well, the height of the prism, this is where it gets confusing, the height of the prism is the distance between the two bases. If you were to stand this up and have the triangle on top and bottom, then your height would obviously be 6. I mean, that'd be pretty easy to tell. But this is the height of the prism. The 3 is the height of the triangle. So they're different h's. They mean different things in these cases. So again, the height of the prism, this is the prism, is 6. So as you can tell, different numbers get plugged in. Now, it's just multiplying all the way through. So 4 times 3 is 12, times 1/2 is 6, and 6 times this other 6 is 36 centimeters cubed for volume. Very, very tricky formula, but you got to pay attention to know what that's talking about. Let's go to example 3. Example 3 says a wall is being constructed to enclose 3 sides of an aquarium that is a rectangular prism. It's 8 feet long, 5 feet wide. If the aquarium is to contain 220 cubic feet, 220 cubic feet, that's what that is. Cubic feet of water, what is the height? So we don't know what H is, but we do know the width is 5 and the length is 8. And whenever they tell you it's 220 cubic feet, so again, since we're talking about volume and we're talking about rectangular prism, start with the volume formula for a rectangular prism. So in this case, you use V equals LWH and then plug things in. This would be equals 8 times 5 times H, and we don't know what that is. But I do know 8 times 5 is 40, so I can divide both sides by 40, and that will tell me what H is. So the zeros dividing by 10 would simplify that to 22 over 4, which would be 11 over 2, and 11 divided by 2 is 5.5, and I didn't have to do any division there at all. Just kind of figured all that out in my head. But that would be your final answer for height. And you could check it if you wanted to multiply 5.5 times 5 times 8 should give you 220. All right, let's go on to example number 4. All right, so on this one, kind of a crazy looking model, but we're going to find the volume of this. And I hope you notice there are two shapes here. There's a rectangular prism and there's a triangular prism. So we can kind of do this in two parts. First is LWH, and that's for the rectangular prism, and then the other one would be 1/2 BH. So I hope you notice, those are both just using what we already did in the previous couple examples. So let's do the length times width times height. That would be the 12, 10, and 8. So 12 times 10 times 8, just length times width times height. We end up with, looks like it would be 960. That would be feet cubed. Now we're going to use, for the triangular prism, this is where it gets tricky. The 1/2 BH is just the triangle. So the height is 3 and the base is 10. So it's 1/2 times 10 is the base times 3 for the height of the triangle. Now the other height is the height of the prism, which in this case is going side to side. You have to remember, you're thinking of that basically turned, so the triangles are on the top and bottom, and that is 12. That's where this gets really tricky. But now when we multiply, 10 times 3 is 30, times 1/2 is 15, 15 times 12 looks to be 180. So we end up with adding 180 plus 960, and my total comes out to 1,140 feet cubed. All you did was add the volume of the top plus the volume of the bottom, and that's your final answer. Let's go ahead and move on to example 5. All right, so in 5 we've got this cylinder. It's basically, you could think of it as a circular prism because it has two bases. But our formula here, you start out with this big BH formula, and what formula goes in for big B? Well, that would be the area of a circle, and the area of a circle is pi r squared. So, and then the h just drops down. So that's the formula for a prism, would be pi r squared. You find the area of the circle and then you times it by the height, and that gives you the volume. So let's start plugging things in. We've got 3.14, which is pi times r squared. R is 5. 5 squared times the height, which is 15. And 5 squared is 25. So now we have 3.14 times 25 times 15. And we have an answer. If you multiply all three of those, you get about 1,178.1. This will be feet cubed. So the only part I left out here is all the calculation of the multiplications. All right, that was actually example A. Let's try B. Here's 5B. All right, B says the diameter of the base is 16.4 millimeters and the height is 20 millimeters. So they don't give you a picture, they're just giving you what you need. And they say find the volume of the cylinder. Since it's a volume of a cylinder, we use the cylinder volume formula, pi r squared h. And since they give you the diameter, you need to find the radius, which will be half. Half of 16.4 is 8.2. So now we've got 3.14 times 8.2 squared times the height, which is 20. All right, and basically, you know, if you were using a calculator, this becomes really simple. I think you should go ahead and do that. After you've multiplied all those, you get about 4,224.8, and that would be millimeters cubed. So save the time of multiplying all those, but with a calculator, you know, that would be okay to do, so you can get your answer. All right, that is all for 11-2.